Kia ora Year 12 and Year 11. This is the start of some AS exam revision that I'm going to do videos of. So here I've just picked out a couple of questions from one of the Pure 1 papers. There's one on trig and there's a differentiation question that looks really tricky but really is just the chain rule and some Year 9 geometry. So if you're watching this and you're in 12 MCA, I might go a little bit faster than you're used to, so just leave me a comment if there's anything you need clarifying. Okay, so these are the two questions here. I'm going to do question 4 first, which is a trig identity one, and this is how it goes. Well, that's the examiner's report. I'm going to look at that later on. Okay, so here's the trig question, and it's got a pretty common setup, which is that we have to prove an identity in part 1, then we have to use that identity to solve a trig equation. So let's see what we've got. Well, looking here, we've got to prove that this is equal to this. So I'm going to start on the left-hand side and work my way through to the right-hand side. And remember, it's AS, so we've got a pretty limited number of identities that we can work with. So on the left, we've got this 1 over sine x minus 1 over tan x squared. Now, there are lots of ways you can do this, but the easiest way I found was to just leave that as 1 over sine x. And remember that tan x is sine x over cos x. So 1 over tan x is cos x divided by sine x squared. So I'm not doing any squaring yet. I'm going to clean up what I've got in the brackets here. So here we get 1 minus cos of x over sine x squared. If I square the numerator and I square the denominator, I'm going to have a look now at where I'm trying to go. Right, so you can see in here I've just got cosines sitting in the right hand side. And you can see that I'm just about there with the top line with the numerator. So let's think about how we can change sine squared x into something with cos squared x. So just leave the numerator alone, 1 minus cos of x squared. Sine squared x is equal to 1 minus cos squared x. And that's because cos squared x plus sine squared x equals 1. And you can see now that I've got the difference of two squares here. So we've got 1 minus cos x times 1 minus cos x in the numerator. And I've got 1 minus cos x times 1 plus cos x in the denominator. And I can divide out my common factor. 1 minus cos x over 1 plus cos x, which is what I wanted. So which equals the right hand side as required. So that's the first part of the problem done. Let's look at the second part. So hence, solve the equation blah 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 is equal to 2/5. So remember that even if you had somehow mucked up that first part, you could go on and successfully do the second part. So we've got 1 over sine x minus 1 over tan x squared is equal to 2/5. But we know that we can rewrite the left-hand side as 1 minus cos x over 1 plus cos x is equal to 2/5. Cross multiplying and then cleaning up, we get 5 minus 5 cos x is equal to 2 plus 2 cos x. Simplifying, I get 3 is equal to 7 cos x, giving me cos of x is equal to 3/7. Now we're asked to solve that for values of x between 0 and 2 pi. So it's time to draw a graph and just check what we're after. So here's my cosine graph between 0 and 2 pi, and I'm looking for the values where we cross that horizontal line. So you can see we're going to have two solutions. I'm going to call them x1 and x2. Now, if you're watching this from A level and we've just finished a whole lot of trig, I'm not going to do general solutions on this. Okay, we're going to start by saying that x1 is equal to the principal value, so the angle whose cosine is 3/7. That gives me 1.13. And using the symmetry of the graph, we get the second value, which is going to be 2 pi minus that angle. Right, so here's 2 pi here. So I'm going in that way, and then I'm coming back this way. That gives me a value of 5.16. Now I'm pretty sure that on the cover page of this you were told to go to 3 significant figures. So just be careful that you follow those instructions. Okay, so that's the trig question done, and that took 5 minutes. Now I'm going to do the volume of the triangular prism question, which I think is harder, less obvious to see where to start. So let's carefully pause the video, and I want you to read through it and see how far you can get with setting this up. It looks really daunting, but you need to go back to year 9 and think about what is the volume of a prism. Okay, so figure 1 shows us an open tank in the shape of a triangular prism, and we can see it's 40 centimeters long. The vertical ends are identical isosceles triangles, and we've got this angle here is 30 degrees. And the tank is fixed in position with the open top being horizontal. Water is poured into the tank at a constant rate of this. So this is dV by dt. And the depth of water is h centimeters, right? So we've got this depth here, h, is changing over time. So the first part of the question just says to show that when the depth is h centimeters, the volume is given by this. So let's start by writing down what the volume of a prism is. So the volume of the triangular prism is equal to the length times the area of that triangle. Right, now that triangle is going to change. So it'll start off as a very small triangle and it will gradually grow. And at its biggest, it's going to have area ABE. So let's see what we know about how that tank is filling up. It's not a fish tank. Well, we know that that's 30 degrees. And we know that that's 30 degrees. And we know that that is called H, and that's point E. Okay, if it helps you to think about just the big triangle of ABE, you might want to start like that. Okay, but it doesn't matter where we are, those angles are going to be 30 degrees. So we're going to split it up into 2 triangles. The area of a triangle is half the base times the height. So the volume is going to be 40 centimeters times half of whatever this is times the height here. And we want to end up with an expression with h. So it's half times the width times h. Okay, so splitting this triangle up into 2 gives me h here, 30 degrees here, and let's just call this width here x. And we'll call this one here x as well. So what can I say about the link between x and h? Well, let's go back to year 10 trig. This side is the opposite. This side is the adjacent. So we've got tan of 30 degrees is equal to h over x. Remember, we're trying to get to an expression which has just got h in it. So tan of 30 degrees is 1 over root 3. If you're having trouble remembering that, here's your special triangle: 1, root 3, and 2. Okay, so 1 over root 3 is equal to h over x. Now we don't want x in our expression, we just want to get rid of the x. So we're going to write x as the subject of the formula. So x is equal to root 3 times h. Remember, we're trying to get the volume, and the volume is the length of the tank thing times half the base, which is 2x, times h. So V is equal to 40 times a half times 2 times root 3h times the height, right? So it's the length times half the base times the height. Let's clean this up, and we get 40 root 3 h squared as required. So I think if you take that slowly, it's not too bad. But lots of students apparently had real trouble with this question. So that's the first part of it. How many points was that worth? Yeah, that was worth 3. Now the next bit is where we have to differentiate. We have to find the rate at which h is increasing when h is equal to 5. So we're going to use the chain rule for this. So what are we given? Well, we're told that the water is flowing in at a rate of 200 cubic centimetres per second. And our goal is to find the rate at which the height is changing when h is equal to 5. So this is a straightforward chain rule question. dh by dt is equal to something times something. So it's going to be dh by dv times dv by dt. We've just about got this because we know that v is equal to 40 root 3 h squared. So dv by dh is equal to 2 times 40 root 3 h. And that means that dh by dv is the reciprocal of that. So it's 1 over 80 root 3 h. So going back to here, we've got this now and we've got this. So dh by dt is equal to 1 over 80 root 3 h times 200, which gives me 200 over 80 root 3 times 5 when we substitute in at a height of 5 centimetres. That gives me 1 over 2 root 3, which simplifies to 0.289 centimetres per second. Okay, so that's the end of those questions. I'm going to quickly show you the examiner's report and comment on a couple of things. Alright, so it says that lots of students found proving their identity really hard, and that those who started on the right-hand side were very, really successful. Well, I'm not really surprised at that. If you go back to that identity question, it's pretty hard to see where to go if you start over here, so don't do that. Okay, we start in this one. It's clear that if we start on the left, there are some obvious first steps. What else? You can read the rest of that if you pause it. Better if you combine the fractions first. Okay, the second question says that because it was set in context, it proved to be a real challenge with a number not even trying it. Okay, and it said it was best if you found the area of the triangle by half the base times the height, or the other version, half AB sine C. It went better if you didn't try and simplify too early. And most people realised that it was a chain rule question in part 2. Okay, but so well done if you got those 2 questions. And if you would like some more practice on ones like that, I can set up some Dr. Frost worksheets. So just send me an email or leave me a comment, and I can do that for you. Thanks for watching.